Yeah. Should I share right now?
Yeah, go ahead.
Okay. Can you guys hear me loud and clear? And can you see the screen?
Yeah.
Yeah, we can
Okay.
Correct, yes.
Awesome. Okay. Are we waiting for anyone or can we start?
Did we have the 11 in the room? Someone said we were supposed to have 11, right?
Yeah, we have the
Everyone's
11,
here now.
so go ahead and start.
10-4.
Okay.
Actually, hold on a second. I have
Yeah.
to get co-host. I think my co-host just have to record in a second.
Okay. How's everyone doing?
Doing pretty good. You?
Pretty good.
Recording in progress.
I know, but the one is a professor. So
Yeah, start. Anybody also wants to be a co-host and record the?
yeah, because I'm recording right now.
Oh, so can I start?
Before you start, we need somebody else to record just for in case. Anybody wants to do
Okay.
that? Brian, Gabrielle, would you like to be a co-host too to start recording?
Sure.
Gabrielle, is that you or who wants to be a co-host? Can you say your name again so I can give you permission?
It's Brian. Oh, yeah, Brian's right there.
All right, first is good to go.
Okay, I'll start. Okay. Good afternoon, everyone. My name is Abhijit Malvi, and I'm joined by my two group mates, Brian and Angelo. And today we are discussing the idea of how neural networks are used for self-driving automobiles. So before I move on, let me introduce what exactly a neural network is. It is basically a chain of neurons that is run in a network and that receives some information, looking at some patterns and sends it to the main thinking part of the system. For us humans, our main thinking part of the system is our brain, and we also have some neurons that run in our body, which helps us make decisions as we go. Um, Self-driving automobiles are just self-driving cars that can go from one place to another without the use of any features inside the car. So we hear the term of AI everywhere around us, and that's how self-driving cars have been booming for the past 4 or 5 years. Um, we see that a lot of devices connected to the internet are used in self-driving cars, such as voice controls systems that we see in our navigation systems. The voice control system recognizes our voice and gives an output based on what we say. That's because of neural networks. Also, our smartphone, there could be an idea of how we can use our smartphone to call our car from one place without it getting driven by anyone. Um, for this to happen, it observes surrounding objects around itself so that it doesn't crash into anyone or it doesn't break the rules. And that is solved by using algorithms such as convolutionary neural networks and k-nearest neighbors. These are just the two common algorithms used today in neural networks, where there are a lot of other algorithms used, which will be discussed later on. It also looks at or assesses the conditions outside to make sure its passengers are safe, and it creates a natural comfortable workspace to go from one place to another. But with all these solutions, there are also problems, such as the sensors can be negatively affected due to the inaccurate data that it can receive based on the algorithms that is used or the conditions it is in. Due to the vast amount of algorithms that are there today, there could be a lack of confidence in what algorithm we use for it to accurately predict the result. There could be a lack of control. There could also be a lack of how accurate its vision is, because we would always trust our own vision, because even today our visual cortex sees better things compared to what we can trust on a fake human, basically. And due to which it could be hard to be received by the society. So now I'll move it on to Brian, who will talk about significance.
Some of the significance is increasing the demands and usage for self-driving automobiles. Self-driving automobiles can lead to fewer crashes and fatalities. It can also lead to more money in your pocket because you won't have to worry about buying gas. Self-driving automobiles can reduce human error and stupidity, like driving while drunk or driving while under the influence. Some of the objectives they'll give you an insight into what algorithms and technologies are used to make self-driving automobiles more efficient and safe, and how it improves everyday life, and give you a brief history of how it all started. Now I'll pass it on to Angelo to explain what will be reviewed.
Awesome, guys. How are you? I'm Angelo. So we decided to do a literature review for this project. We're going to divide it up in 3 parts. At first, we're going to talk about how the abundance of data is retrieved and how the AI is trained in order to have accurate performance. So at first, we're going to be talking about algorithms, the algorithms that exist and the ones that they preliminarily use for, autonomous vehicles. So at first, we're going to have KNN, which is basically K nearest neighbor algorithm, which is a non-parametric method used for classification and regressions in order to predict data. We also have CNN, which is convolutional neural network, which is deep neural network applied to analyze visual imagery. This is super important because this is the one that they are going to be using the most when it comes to autonomous vehicles, due to the fact that they need to analyze imagery around them, like other vehicles around them, vehicles in front of them, vehicles also behind them, things on the road like stop signs, also the lanes in which we drive in, speed limits. Those are all factors that are gonna apply to us when talking about these autonomous vehicles. We also have RNN, or recurrent neural networks, which are algorithms used for sequential data, and it also remembers input and is great for machine learning. This is extremely important because, like we were talking about before, with the AI, algorithms that are able to remember an input is going to help the machine and the AI feed up into a system and get as much input as it can to literally make it smarter through time. So the margin of error becomes smaller and smaller the more data we have, because the data is going to be a lot more robust by the end. This is also super important because, or not super important as well, but also pretty famous because companies like Google and Apple also use this type of algorithms when they build their systems. And we also have MLP, multi-layer perception, which is another class of feed-forward ANN. Within the first part, we also have, we're going to talk about sensors that collect surrounding data and import it to the cloud server. Going back to what convolutional neural network is, it ties up to that with the visual imagery, and then being able to import all that data into the cloud, and then have it go from there for the AI. In the second part, we're going to be talking about how self-driving can improve safety on the road, which is extremely important. We're going to have sensors that are not going to need human input. They're going to be by themselves, going again to the topic of CNN. We also we want to see how it reduces crashes using deep learning algorithm. Same thing with the cloud, with the inputting for the cloud server. We want these AI to be a lot smarter in the future. And then for the third part, we wanted to take a step further into the future, into the foreseeable future, and we want to see how the state of AI technology impacts our human and our safety in the future. At first, we want to see features inside the self-driving automobiles that will allow humans to not have interaction with said vehicle. So right now we are in 2021, of course, but for the foreseeable future, let's say 2030 and even maybe 2040. Where we are right now is we are adapting to the process or to the reality of actually not having to touch the wheel of the car. Now this is where we start. This is where we stand right now, and we also stand in the place where we are stopping to use the use of pedal and brakes by ourselves. So where AI stands and where they want to be into the future, people want to take it to the point where we will not have any touch interaction, and also to the point where our eyes are going to be off the vehicle. We're literally not going to have any simple interaction. We're just going to stay there, get in the car, and just relax. And also we want to see better performance from them. We want safety. Safety is super important for us and for the people surrounding us. That is one of the big issues that has been happening lately, and that the AI needs to have more robust data in order to make up for this. We also want to see more power resulting in a better economy, fuel economy, and also free air pollution, which is more on the topic of electric cars themselves. But this is also very important when talking about the topic of autonomous vehicles. You can go to the next slide, Abby. All right, we laid up a schedule regarding our project. So the first weeks, of course, is going to be the research, the first draft. Then it's going to be the presentation with the final paper written. Then almost towards the end of the class, we're going to have the final preparation and rehearsal. And of course, the last week of class, we're going to have the presentation and final document submission. Can hit up next. Awesome. So our concluding remarks is going to come to our goal, which is going to be, of course, a comprehensive literature review, which is going to be talking about this insights in technology to providing more solutions for the self-driving automobiles topic. We want them to be more efficient, more time efficient, more accurate, with more better decisions, which need more accurate data. We want it to be safer, again, for us and the people surrounding us, and we want the system to make better systematic decisions. Can you go next? Our references are, of course, we found out 3 articles pulled up from the IEEE, divided into topic 1, topic 2, topic 3. We're not really going to talk much about them right here, but we are going to talk about them further in our project and final presentation. Of course, we will make our presentations based on this, and we'll take it on from there. Thank you, guys. Do you guys have any questions, any advice, constructive criticism for us?
Yeah, I had a question actually. So earlier you guys said that self-driving cars mean less gas, but do self-driving cars need to be electric?
Not necessarily.
So what does it mean? Why would you guys say less gas? I think you guys said like less to little to no gas or something.
Yes, we were just talking about the fuel economy, and then I made a touch that, of course, the purpose is to move into a full electric environment. That's the goal, and that's what we will be talking about. But there's cars that, of course, we're talking about an autonomous realm. You have assisted driving, and then you have fully autonomous. Of course, you have the fully autonomous going in with the Teslas, and now with Ford coming up with the Mach-E, Mustang Mach-E, and then other companies coming up with that as well. But with that, we were talking about assisted driving as well, which is our reality, which is where we stand today, which is our 2 realities, basically, where we stand and then into the future.
Yeah, I wanted to add that depending on how we are going for the past 4 or 5 years, a lot of people are moving away from cars that are fueled with petrol or diesel, and are moving more into electric cars where you'll save a lot of money from petrol. So I think that's how the future will hold, that there will be self-driving electric cars where you can just charge it anywhere you want and not having to worry about spending your wallet on diesel and petrol.
Okay, thank you.
Yeah, no problem. Any other questions, advice?
Yeah, I got a question. So in regards to like your guys' research, are you guys gonna try and focus mainly on like American self-driving companies and like how it relates to like us, or are you gonna try and look at like global technologies and see if like because of competition, there's like different areas of neural networks that can help improve the convolutional neural network and recognition and stuff like that?
So yeah, go ahead, Abby. You go ahead.
Okay, yeah. We will look at this more at a global scale of how all the countries are looking at this situation and seeing how they're moving away from cars driven by petrol and moving more into self-driving cars and how AI ties into that.
Oh, dope. All right, thanks.
No problem. Good.
How long do you guys think it'll take for us to normalize self-driving cars? Because right now I would say that assisted driving is pretty normalized in our cars.
So within, again, this is going to be, of course, more with the final presentation and the final report. But when we were doing our research, we saw that they were divided up. The years were divided up. Everything started in like the year 2000, and then right now where we stand, like I said, we're getting used to not having our hands on the wheel and our feet off the pedals. So the forecast is that between 2030 to 2040 is going to be more normalized and accepted in society, and it's going to be basically our new reality. But you're definitely right. Where we stand right now is mostly just assisted driving with image recognition, lane road assistance, braking assistance, and whatnot, which is where we stand at the moment. But the goal is that by 2030 and 2040, that time frame, everything will be more normalized.
Do you think it's gonna be like a smooth transition from assisted driving to autonomous driving? Something like if you have like half the cars assisted, half the cars autonomous, like if the autonomous stuff is all following the rules and you got like an assisted driver that's not, it'll have to like adjust and count for that. Like if they're all autonomous, they'll all just follow the rules perfectly, right? So I'm just wondering if you think it's gonna be like a smooth transition from assisted to autonomous, or if there's gonna be like an oopsie period while we get there.
Well, I think that what I hope is that we have more of a smooth transition, and also not only because of that, of the fact that because the cars are being introduced, Teslas are there, but how many people can afford a Tesla? How many people can pay for that? So when I was talking about it, I was looking at it more as a commodity. Right now it's not really a commodity. It's more of a semi-affordable luxury, because you have Teslas that might be 30 to 40,000, but the reality is your average Joe cannot afford that. So I hope it is a smooth transition, but like I said, it's gonna take some time, and I think that assisted driving is gonna be here for a little bit, until for at least like 10 more years, and then by 2040, I'm one of the people that at least sees that that time frame towards the end is going to be a good timing where everything is going to be more normalized. But everything has to be affordability, has to do with affordability, availability as well. Like here in America, like good, we have Teslas, but maybe in countries like in South America where I'm from and stuff like that, we don't really have those. It's more of super expensive luxury, and we don't really have that. We don't have charging stations. We don't have stuff like that. So it's going to be, hopefully it's a smooth transition, but it for America at least is going to take some time, and then for the rest of the world I foresee it that it's going to be beyond 2040. But it's a super interesting topic though to talk about, so that's why we chose it. Is that it? All right. Thank you guys. Appreciate everything. Good job, guys.
Well, thank you.
No problem.
Is there anybody that would like to go next? No group.
If no one volunteers, I'll go.
Who said that?
Yash.
Oh,
I'll go.
all right, you go ahead and go. Share your screen.
Okay, hi, my name's Yash, and I wanted to propose investigating Bayesian learning networks. So like they were talking before, AI has come a long way, and there are also a lot of ways to implement AI, and they can make decisions in various ways. You could do reinforced learning, where you run the simulation a few times and you tell it based on a reward system what to do. You could have Markov processes where there's a transition, probability of transitioning to different states. There are neural networks. There's also like just decision trees and state machines where based on where you are, you can only end up in other places based on like the next states. And all of these require some data that the AI needs to make some decisions. Whether it's reinforced training, like I said, where you just simulate a few times, or actually a lot of times, and you tell it, hey, you're not doing this right, you're doing this correctly, and you give it some reward system and it learns from it. Or you could have real-time data where it has to make decisions based on its current state, like Markov processes and decision trees. But what happens when we have limited data, when we don't know, when we're not certain of what we know, when there's other factors involved? Well, that's when Bayes nets come in. So Bayes' theorem is, we learned it in high school stats, but basically it's given two events, two independent events. You want to know the probability that one happens given another. So top right, we see. So there's the probability of A given B, and using the probability of A occurring and the probability of B occurring, we can figure out the probability of A happening given that B happened. And the key here is that they have to be independent. They can't affect each other, because then what is the point of it? So this is a type of probabilistic modeling where we have a lack of certainty in our data. So like I was saying earlier, all the data that we're given for the AI to make a decision, you're not always certain that that's correct data. And things like reinforced learning, oftentimes you are, and that's why you simulate it a few times or a lot of times before you actually run it in the real world, because you want it to learn. But a lot of Bayes nets rely on just using real-time data. So the decisions are made at the bottom right. We have a simple Bayes net. So as you can see, there's 4 nodes. There's cloudy, sprinkler, rain, and wet grass. So this essentially is, given that it is either the sprinklers were on, or that it was raining, we'll have wet grass. Or if it's cloudy, will the sprinklers be on, or will it rain? Now, a key thing to note is that they depend on each other. So sprinkler depends on whether or not it's cloudy. Wet grass depends on whether or not it's sprinkler, and it depends on whether or not it's raining. And there are some set probabilities of these things happening. For instance, here we have the probability that it is cloudy, but the sprinklers are not on is 0.9, and the probability that it is cloudy and the sprinklers are on is 0.1, because if it's cloudy, it might be about to rain. You don't want to turn the sprinklers on. So these are, as you can see, they're not independent. So you can't calculate the probability of it having wet grass without understanding the probability of it raining or of it having sprinklers. So when you propagate that, when you propagate the probability down, then eventually you can come to a decision on what to do. In the real world, though, you won't have probabilities that are set like this in tables. Oftentimes, you'll have a sort of distribution. You'll understand how your data should look. So on the left here, we have a simple normal distribution. And you can see that the distribution is shaped differently depending on the set parameter. So when sigma is around 1/2, you have this long distribution that's purple. So you have a pretty good chance of being anywhere under that. But with a sigma of 132, you have this very narrow distribution. So most of the probability of things happening are going to be within here. And so in the real world, what we're actually going to do is estimate this distribution and the shape, and then make a sample a probability out of that, and then use that. So some topic. Like I was talking about before, a big use case is when you don't know a lot about your data, but why would you want to rely on Bayes nets? What are its pros? What are its cons? You know, and I also wanted to compare Bayes nets against other decision-making tools, other AI models such as neural nets and decision trees, state machines, etc. Why are Bayes nets better, or rather, when should you use Bayes nets over the other tools? I really wanted to look into a basic Bayes net implementation as well. I know there are some out there, but I haven't personally seen any yet, so I wanted to look into that. And a huge concern of mine is the pitfalls of Bayes nets. I see a lot of problems in having data that's uncertain. How do you make a decision when you're not fully sure that's a correct decision? So I really wanted to explore that as well. But from my basic research before, a huge part of Bayes nets are parameter estimations, as I was talking about earlier, where you don't know the set probability, but you might know what the data should look like. Maybe it's a binomial distribution, maybe it's a Gaussian distribution. You just need to estimate the parameter to know where your probabilities lie and what your options are. But there are a lot of challenges in this, where when you don't have a lot of information to go off of, you also lack some of the things that make Bayes nets what they are. You don't know maybe the conditional dependencies. You won't know, or you want to assume some things, but you don't know if you can assume those, if they make a huge difference in your decision or not. And like earlier, you may not understand your distribution of your data well enough. So the problem is rather easy to come across, like we were talking about earlier with this Bayes net. It seemed pretty straightforward, where it's like the wet grass is dependent on whether or not it rains, which is dependent on whether or not it's cloudy. And this is easy to come up with, but there's a lot of factors they left out. Is there a storm on its way? That would affect if it's cloudy or not. Are we just supposed to assume it's not stormy? We also, just the weather, what is the temperature like? That'll affect whether it rains too, not just whether it's cloudy. So, or even sprinkler, like maybe your sprinklers are broken. Are we going to include that somewhere here, the probability that the sprinklers are broken? So you have to start assuming a lot, but the more you choose not to assume, the more expansive that problem becomes, and it becomes really hard to solve and describe, because it's too much and it's overwhelming. Another challenge I've run across is definitely the support for coding. I saw a lot of libraries in Python that allow for discrete distributions, so things like the probability tables I was showing earlier, but there wasn't a lot for continuous distributions, such as just plain Gaussian or binomial. So I wanted to look into this as well. So yeah, in the end, I just want to make a comprehensive literature review on these Bayes nets, and then compare them with other tools to understand why you would choose them or why you not as an option. And that's all. Thank you. Any questions?
Yeah, I was just curious. So while you were researching, did you come across any real world problems where Bayes nets was a solution to it?
Not, so I did, but a lot of it were structured around like this isn't the perfect solution for Bayes. BayesNet's not the perfect solution for this problem, but let's try to use Bayes to solve this problem. And a huge thing, like I was saying earlier, was weather prediction, but also things like making decisions in real time, where it's like, okay, if, for example, if someone, if you were going to school, right? It's just, oh, I have homework due, so I have to take all this stuff. And it's like, what is the probability of me leaving this stuff? And based on that, what is the probability? So these are all like problems they just came up to understand BayesNets, but I haven't seen any like proper implementations of it.
Okay.
If that helps, yeah. Any other questions? No? Okay, I guess that's it.
All right, thank you for your presentation. Is there any other group that would like to go next?
I'll go next.
Who said that?
Kenneth.
All right, go ahead and share your screen.
Give me 1 second. Screen. Am I showing just the PowerPoint? Okay, yeah, I believe so. Okay, so our topic is going to be system identification using neural networks. So, I'm sorry, give me 1 sec. All right. So system identification is basically the process of estimating the parameters, or we could say the relationship of input and output data in a system. It's present in like multiple fields, but for this review, we're going to be discussing it in terms of control systems. We decide on this topic due to the demand for it, since systems like nowadays just will continue to grow in complexity, and they now are getting like too difficult for human calculation. So we rely on computational techniques and methods to solve them, and this is where neural networks come in. With the implementation of neural networks in system identification allows us to learn hidden patterns and relationships between data in a system, which will then lead to better estimation of the system's parameters. And in this review, we'll mainly discuss different types of neural networks and their implementations for system identification. So we looked at many and decided on 3 types of neural networks to review. The first type is a convolutional neural network, and there's an implementation called DynoNet, which is just an architecture that uses it. The second type of network we're going to do is recurrent neural networks, which are present in these 2 papers. One is a general implementation, and the other focuses on a high order system implementation. And the third type of neural network that we wanted to study was artificial neural networks, which is present in the last paper. And now Gabe will continue.
Okay, for the literature review structure, we were going with the basic points on the current implementation, where we'll start off with identifying what system identification is, some of its applications, like when it occurs inside of a neural network, like identifying specific parameters and pretty much how different neural networks interpret input data and practically would output it, stuff like that. The next part would be on the DynoNet, specifically on the convolutional neural network. How does it learn parameters? How does it identify what system identification of it? And for the next topic would be system identification using artificial neural networks. So that would be mainly on the high order neural network, And the same thing as DynoNet, we would explore which how does it learn parameters, how does it identify system identification, and pretty much same thing for the next one. Using the recurring neural network, like how does it learn parameters, how does it differ from the other two, and how does it identify system identification? And then the last part of it would be to actually compare these three, or yeah, compare the three and see how they differ in efficiency and speed and like what actual usage they could actually pose to be. This is the basic schedule we have going, where obviously this week we're working on the proposal and how to present it. The next week would be actually researching and start developing, research for the paper itself. The next week would be for actually writing the paper. Week after that would be to develop the presentation and to finalize it. And then obviously the last week would be presenting our data and findings to you guys. For the focus areas, my partner is going to be focusing on the convolutional network on the DynoNet and the high order neural network. And I would be focusing on the recurring neural network and more on the comparison between the three. So concluding, the whole goal of this thing is to compare between the three neural networks and how each of these three differ on the system identification part of it. As like my partner said, as more problems become more complex, human minds can't be used to actually properly identify system identification and how inputs should be like interpreted on a more grand scale for bigger problems, and identifying which of these neural networks is actually best for this application, based on like speed, efficiency, errors, and pretty much things like that. And hopefully going into more detail on like what applications this technology could have and how it benefits us in the future. These are 4 references we got off of the whole Google Scholar. And pretty much they go in order of our current implementations with the convolutional network for the first one, the recurring neural network for the second one, the high order for the third one, and then just a general system identification using neural network paper to help us compare between the 3 types. And that would be it.
And that's it.
I appreciate you guys listening. Any questions?
Yeah, so at one point you said like you're gonna compare the 3 to find out which neural network is best for this application. I might have just missed it, but what's this application? Like, what are you trying to find neural network for?
It wouldn't be a specific application, more or less it's going to be like a comparison on which one would be better use for like a group of tasks or a category of tasks. I guess it's not just one specific application.
Yeah, as the system identification is more of like a general term, because a neural network can be used for many different tasks, but the system identification is kind of how that specific neural network would identify, given any input, like how it would translate it into like the desired output, how it would continue to learn and develop off the inputs.
All right, thank you.
Say we as a society, as the world, we get neural networking working fine in XYZ, right? What do you think our first priority would be to use that neural network for? Do you think the best thing to use it for would be?
I'm a little confused on what you're asking. Like you said in XYZ.
Say we have it working fine. We have our first prototype and it works, right? We have a neural network and it works. What do you think the most important thing what would you think the first thing we'd use it for?
That's pretty.
It's a vague question.
I don't know what the best thing would be. I know that it's a really interesting topic I was looking into was actually, I don't know if you've ever heard of it, but a lot of like medicine actually uses like these little robots that kind of like actually perform the surgery itself. And I know a lot of the neural networks are actually starting to begin to actually like perform these surgeries or like help aid the surgeon in more complex surgery. So hopefully something like actually that would help humanity rather than, something kind of a little mundane medicine wise, I guess. I don't know. I think it's that the neural networks have so many different capacities that it's like a pretty general thing. I wouldn't know where to even begin, like on which specific topic.
And any other questions? Okay, well, that's it. Thank you.
Yeah, appreciate you guys.
Okay, thank you. And I believe we have like 2 more groups left. So who wants to go next?
I'm fine going.
Who
I'm
said that?
Elijah.
All right, no problem. Go ahead.
Alright, can you guys see the screen and hear me okay?
Yeah, I can hear you fine. I can hear you.
Yes.
So I'm Elijah Rodriguez. Basically, for my proposal, I'm looking at the push for accurate, just standard automation and image recognition, specifically using convolutional neural networks. So basically, automation is always constantly expanding. I'm going to be probably focusing on these 2 industrial applications. Like a common example of that would just be your standard robot arm with a camera attached to it, using CNN with object detection to, accurately move objects, perform a certain task, et cetera, et cetera. Medical applications is where it gets a little bit more interesting. And that's where this image recognition stuff comes in. I don't know if you guys took algorithms for machine learning or if you guys ever have to take it. But last semester, we did an assignment where we used a neural network with a bunch of pictures of lungs. Like some had COVID, some had pneumonia and stuff like that. And we would use it to try and like predict whether or not like that specific picture of a lung had COVID or not. So like that's a pretty, unique diagnosis that you can do with image recognition. You can also use it for discovering like the exact type of drug a patient needs based on just running off previous data and using a symptom check, and then you can use that network to keep like constantly checking and looking for new developments. And another one I found was identifying skin cancer, based on like the image of your skin cells. So, if we do it properly, we can accurately move towards getting like very, very accurate diagnoses for multiple types of cancer. So some of the problems that are kind of plaguing, especially like CNNs right now, are just standard accuracy. One of which being the bias problem, which is essentially just if you have a class imbalance or if your data is not split properly, you will have like a ton of issues with bias, especially with overfitting. Overfitting, if you guys don't know, especially is basically just if you only train on like a training set and you try to give your model to a completely new fresh data set, most of the time it's probably just going to fail completely because it's used to just predicting one-to-one your previous training set. And if you use that with image recognition, you're just not going to be able to detect any new objects or if there's like anything in the way. Another issue is network breaches, especially in the medical field. Your data can potentially be like stolen in a cyber attack. So one of the things I'm going to be looking at is trying to improve network safety. And the other thing I noticed was that image recognition can be fooled by physical and digital changes. An example I've seen of physical is like if you have a stop sign, but you put like stickers or writing on it. If you have a poor image recognition, so like software or a model, it's not going to be able to recognize that that's a stop sign. So going back to that group that was like talking about like self-driving cars, like if you don't improve like that algorithm, then like you run the risk of like the car not recognizing the stop sign or not recognizing a red light and potentially like causing an accident. Digital alterations include like if someone adds like a lot of digital noise to a picture, it could potentially mess up the recognition and the program cannot like classify it correctly. So for impact, I'm going to be looking at how it could add new job subsets, because instead of just laying off workers, you can now train these workers to accurately run, update the entire neural network, all the software involved, code it from scratch, or just using libraries. It could potentially save lives as well. Like I said before, there's a lot of preventative measures, especially with like that skin care and the skin cancer, and COVID diagnosis. You can recognize medical issues either like as they're happening or as a preventative measure, especially once like the future improvements to accuracy and biases are made. And hopefully, if you increase the network security, you'll be able to protect your client information, as well as just like protecting your overall health, because now you'll be able to accurately be able to determine if you need drastic medical attention or, you know, if you'll be fine. And then also just generally quality of life, specifically in the industrial department. If we have improved automation, you can now not have people, you know, risk their lives doing like dangerous machine jobs. You can now have them instead just operate and update the automation and neural networks. So basically, for my overall objectives, I want to research and find new and innovative methods that people are working on that are addressing those previous issues, specifically for CNNs. So basically, my thought process is I'm going to be doing just a general overview of CNNs and how they relate to automation and recognizing images, as well as image processing, and you know how you go through the pipeline of dealing with that. I want to do a thorough outline of all the ethical problems, as well as the technical issues that have prevented neural networks from, you know, branching out and being used very mainstream. Because if you do it improperly, you could have a situation where it's either just not beneficial to us because it's making too many mistakes, or it's controlling too much, and then you can, you know, you run into basically like Skynet type issues. And then I'm gonna finish it off by doing current works of what people are doing, especially looking into the new research, which I'll explain later in the research paper section. So the areas that I'm specifically going to focus on because I'm doing research are just the overall neural network architecture, specifically the computational memory requirements, you know, like dealing with how much power, how much memory do you need? Can the computer handle, you know, running that many epochs? Can the computer handle all these hidden layers? Just the general accuracy, you know, so looking at loss functions, going into like the real like mathematical side of it to try and figure out how we can just like get a general increase in accuracy and make it more reliable. One of the research papers I saw had a really interesting thing where they're using IP-based encoding, which I'm not going to get into like too much detail, but basically it just sends the IP through the hidden layers, and you can use that and have it keep all the data and use that to kind of keep it like secure and tighten it and localized. Another paper dealt with combining networks. So instead of just trying to make one network do a bunch of different tasks, you can have smaller networks do their own individual tasks, and combined they'll have a full, you know, general process, and they can do it successfully. And I'm gonna try and analyze how using different types of hidden layers, different types of non-hidden layers, and changing the weights either by hyperparameter tuning or manual weights can affect the general performance and accuracy of the network. My concluding topic is just I basically want to try and understand and apply in like these new solutions and new research topics to try and just get the accuracy up so we can use CNNs more reliably and in the mainstream. I want to try and find ways that we can improve data security, so then that way people don't have to worry about constant cyber attacks and losing their data, and introduce these, as well as addressing job security a little bit, just because I feel like that's a point of contention, especially with automation. But I think there's a way that you can do this properly without risking like too much job security. These are my reference papers. I'm not going to go too much in depth, but basically this first one was just a general trend and challenges that are currently facing AI. This is the one that these people did a study where they kind of grouped a bunch of networks together, and they found that the accuracy did kind of go up. So I'm going to go in depth on that. And then this one was trying to deal with attack detection, like what I was talking about with physical alterations to an image, where it can affect the outcome of whatever is trying to be classified. And that is about it. If you guys have any questions, I'll answer them. All right, I think I'm good then.
No problem. Thank you for your presentation.
Thanks.
And does anybody know who wants, like, do you want to go next? I think we have two groups left actually now. Two groups left now.
I'm down for us to go next.
All right, we can go then. Whoever share the screen.
Yeah,
can
I got it.
start.
Let me
So we're doing our project on artificial intelligence on information privacy on like our private devices such as like your phone or any basic thing like that. My name is Ricky and my two partners would be Alexander and Shay. If you didn't know, yeah. All right, so for introduction, if you didn't already know, like artificial intelligence is kind of taking over our daily lives right now. We're using Siri or Alexa to answer like the simplest questions, like what's 2 + 2, or what's the definition of a specific word at the snap of our fingers. Even though we probably already know the answer to that, we just want to be like extremely safe about it, so we just ask anyway. And it's just really easy to just ask Siri for an answer and being able to get that answer in a matter of seconds. And also, as we know right now, as we talked about previously, there's Elon Musk, and he's using artificial intelligence in order for your newly bought Tesla to be able to use the self-drive feature. And from like watching his different presentations about these different cars and different things like that, that's like only the beginning for him, as he plans on using AI to further improve his Tesla cars to add more practical applications that use them. And in addition to that, we're using Uber or Lyft. Well, I know I am, at least when I go out or whatever the case may be. I'm using Uber or Lyft to be like more safe, but and those apps are using artificial intelligence too, because they want to improve our quality of ride experience. So I'm pretty sure like Uber and Lyft, they have created an application called One Click Chat, which is basically a way to like give you a way to communicate with your driver when you're asking them where they're at or how far they are or whatever the case may be. And I know that doesn't sound like it's using artificial intelligence, but within that feature, there's something embedded within it called intent detection, which is basically trying to predict like the message you're trying to send to your driver based off of like numerous previous conversations you had with drivers in the past or customers that have had in the past, so they can kind of predict what you want to ask or predict what you want to say. So like in reality, before you know it, everything we use in our daily lives will involve some form of AI, but like at a significant cost of protecting our privacy. So, that's our motivation behind choosing this topic. Like, we still know AI is brand new to us and there's endless possibilities for AI. But we're still a long ways away from perfecting the current level of artificial intelligence that we're at now. So as we go further along into perfecting AI, we need to know in what ways is AI improving our lives, or is it making our lives easier or better, or is it really doing more damage than good because it's ultimately ruining the little privacy we do have? And that's the question we have to answer, basically. Is sacrificing our privacy a necessity that comes with using AI? In order to do that, like, we must explore the possibility of pre-existing AI techniques in cybersecurity. So as I said before, AI is still a relatively new concept, especially in the context of cybersecurity. So if you don't know what cybersecurity means, it essentially means is like it's based on rules and interactions. So you get like cybersecurity based off of like rules and interactions with one another, and then AI is based off of pre-programmed knowledge. So in order to give the consumer all the perks of AI, some privacy restrictions must be lifted. Like, for example, if you have your iPhone locked and you want to use Hey Siri, when you use Hey Siri, you're technically unlocking your iPhone just by like the sound of your voice. So now you basically unlock your iPhone with no Face ID, no passcode or fingerprint scanner. And if somebody, say for instance, sound like you and they say Hey Siri to your phone, they can unlock your phone and get into your phone and be able to look at private information or different things that you didn't want to be, given to another person. And like I mentioned before, with One Click Chat with Uber and Lyft, there's that intent detection, which basically uses your previous conversations with other people that you've gotten rides from. They're basically taking all that information before to kind of figure out what you're going to say next or what a customer would say next in the situation. And if you use Alexa, you're basically giving Alexa like connections to all your devices, whether it's your phone to play certain music, whether it's your Fire Stick remote app, or whatever the case may be. You're basically giving all that information away for free. So all of this has major implications we may not have been aware of previously. We're just kind of using it. We don't really know that it's affecting our privacy. So we're just giving things away to just be private to make our lives just a little bit easier. And now Alex will talk about the significance of all of this.
Yeah, so why is this important? You know, well, personally, I have plenty of personal data that I would not want anyone to see. If someone were to learn my email password, they could log into my PayPal, which is linked to my bank, and now they have access to my bank account. And all it takes is one depressingly small transfer to make me destitute and unable to buy the textbooks I so desperately need. Privacy is not privilege, it is a right. And any amount of personal data being misused can like drastically affect the rest of a person's life. How do I go to the next slide? Did I just ask you guys?
Sorry.
Thank you.
Sorry.
So yeah, so we understand the importance of privacy. It's like, hey, this is your whole life. But how big a risk does integrating artificial intelligence into our daily lives actually create? Like, is AI really affecting our privacy? Short answer, yes. Siri is basically always on and listening to you. And according to one whistleblower at Apple, Siri has overheard many confidential conversations, including drug deals. If we're talking about conversations that I would want to be kept private, my drug deals are pretty up there. I mean, drug deals in general. But that's just one whistleblower's report. How about a quote from the chair of the UK's Parliament Digital Culture and Media Sports Committee saying that Facebook rewards companies with access to data that others are denied, i.e. social medias are just selling our personal data. Hey, this guy searched for dog food. Let's recommend personalized ads for collars, bowls, treats, and toys. So it kind of sounds like a win-win. The companies get to market to the individuals that would purchase their products, and the individuals get offered products they're interested in purchasing. The downside is that everything is way too hush-hush and secretive. Like, we have no way of knowing what data or even what kind of data is actually being collected. Maybe they just skim our search history. Maybe they have a repository of all our passwords, credit card numbers, and social security numbers. There's really no way to know what data they're actually stealing or collecting. So what's the point of like stirring the pot like this? What are we really trying to accomplish here? What is our objective? Basically, we just want to make people aware of the potential risk to their personal data and what they can do about it. Obviously, the easiest answer is just to run away forever and live in a cave or forest somewhere without any digital devices in a 10-mile radius and have a loaded gun ready to shoot any smartphone that dare encroach upon your territory. But that's not a reasonable solution. We're not going to tell you to never use social media again or anything, because we all chose this risk to our personal data. Most of us, more so our generation than any other, I believe, understand that's give and take between risk and reward. You get a free and easy way to connect with your friends, along with seeing fun pictures and videos in the palm of your hand, and Zuckerberg gets millions selling your details to advertisers. Most of us actually understand that risk, but we want to motivate people to lessen that risk, using a virtual private network to make your search history harder to steal, or two-factor authentication to make your accounts harder for an outsider to log into. There's a lot of quick and easy things you can do to protect yourself. And most people either believe that data is not being stolen and misused, or that it is and there's nothing that you can do about it, but there is a middle ground. If someone's got a camera pointed at your house 24/7, that doesn't mean you should just leave all the curtains open because they're watching you anyways and there's nothing you can do about it. Like, you can take steps, you can close the blinds. So that's just a weird analogy. We can hear Che talk about some actual hard facts and research.
Yeah, so based on some preliminary research, we found some interesting thoughts and ideas pertaining to our topic. Artificial intelligence has made life a lot easier these past few years. We are now able to have hands-off experiences with our phone, and that is especially useful for when we're driving. And it not only reduces human error, but it allows us to use our phone more easily from a distance and even compensate on the road for our mistakes. Additionally, it's also available 24 hours a day, 7 days a week, so you can just use it whenever you really need it. But these are just a few of the advantages that come with having it. But there are also some disadvantages. So for example, if you have an iPhone, did you ever set your home by yourself? For me personally, I never did, but my iPhone knows where I live and now where I park my car. Artificial intelligence has the ability to take your personal information and use it for both your benefit and your detriment. Your information, like things that you search on Google, can be taken away from you. And I doubt that many people want others to be able to see that. But it doesn't stop there, because technology is always evolving. More AIs are being made, each more complex than the last, and we're getting closer to a self-aware AI. Stephen Hawking touched upon this topic once and warned that if this were to ever happen, mankind might be in serious trouble. Although it's extremely unlikely that that's going to happen anytime soon, there are many examples of how artificial intelligence can negatively affect people today. With our research, we found something called the predictive policing algorithm. It's an AI that predicts where future crimes will be committed based on past crimes. It sounds good in theory, but the problem comes up when you consider the effect that it has on the community. The algorithm will cause certain places in an area, in a district, to be over-policed. And with that, more people will be arrested and the district less funded. This is a downward spiral that can be seen today, but even more so if this algorithm to be implemented everywhere. So the question is, how do we regulate it? Of course, the government will have to make their laws and decide what they will, but will it be as easy as you can use it or you can't, or will there be something in between? And if someone does end up making this super AI that it goes bad, who do we punish? Do we punish them or the people that exploit it? Maybe both. There are just a few things to consider when you think about the detriments of artificial intelligence in our everyday lives. Moving on, we have our schedule for the upcoming months so that we can tackle our literature review. For the first 2 weeks, we're going to be doing our research and taking notes on how artificial intelligence can affect our privacy. The next 2 weeks, we'll be writing our paper and working on the presentation. We'll most likely write our paper first so that we can properly get our thoughts together and then make our presentation based off of that. In the last week, we'll finalize our paper and presentation and rehearse it. Rehearsing will probably take up most this week as we'll be reviewing the things we wrote in week 2 and 3. On the right, we can see the literature focuses, and that's just who's going to be focusing on what in terms of the articles. I'll be focusing on evolution of artificial intelligence, seeing how it has changed over the years and seeing how most likely, in my opinion, we're losing more information as time goes on. Ricky will be focusing on information leaks and seeing if there's any information leaks as a result of an AI. If not, then information that was gathered by an AI being lost. And Alex will be focusing on information privacy, specifically how today's information that's being gathered by AI is being used against us, for us, and how and why it's being sold to others. And these are the references that we used for the preliminary research and the other slides. And are there any questions?
Yeah, I got one. Do you guys think that like a viable strategy for like at least keeping like data security accountable would be like having a public option for AI, so then that way like the taxpayers have a stake in like, then they know that like their money is supposed to be going towards protecting their data and they can take active steps to like ensure that?
I think ideally, yes. I think that'd be a really good idea just because, you know, we the people, right? We deserve to know.
Facts.
We deserve to know what's going on, what's happening with our data, if it's secure or not, and if our information is being sold. It's not right for people to just be able to see our Google searches and do with that what they will. So I think that's a really good idea, and I think that's the ideal.
Awesome. Yeah, thanks.
Any other questions? Or
I have one. AI is like you guys were saying, that the data we're giving them, it needs that data to understand us, right? Is there, and you guys were talking about a middle ground between like giving up your data and basically choosing what you can give it. But do you think there's any use case where you should trust an AI completely?
Maybe if like the whole internet like security thing is still kind of like a gray area. Maybe if it was more well regulated and such, like, because yeah, as like Ricky said in the introduction, like the more access and rights you give the AI, like the more it can benefit you. It is just risk versus reward. So if you're down for the risk, if you're like, you think the data that's at risk is like really not that important or whatever, go for it. Give it all you want. I don't think there can be a like, and nothing can be like perfectly safe. So it's like, you know, it's risk reward.
Yeah, like basically to piggyback off what he was saying is definitely risk and reward. Like say for instance, you have like AI keeping track of your health. Like what if something bad happened with your health, and like when it sees that or notices that, it's smart enough to call 911 for you or whatever the case may be. In that case, it's like amazing that you give your health information and all those different things like that. But sometimes it could be like a risk where you're giving up all your health information and then people are using that to like kind of go into the hospital under your name. They're like seeing, oh, this person has this symptom, and this symptom. If I get this information from them, I can go in the hospital or I can get their credit or whatever the case may be and then run it up. So like it's all about it's really like no middle ground right now, and it's pretty far from being a middle ground. I don't think it'll be a middle ground anyplace soon because I see both like it being a high reward and then I see a high risk, but I don't really see like a really good in between, if that makes sense. Any other questions?
Cool.
All right, and who would like to present? Like I believe we have. Do we have anybody else who needs to present?
I believe I do.
All right, cool. Go ahead and share your screen whenever.
Okay, give me a sec. How do I? Nice. So my topic was artificial neural networks in gameplay, or specifically AIs that work to play games. So to introduce the topic, I talk about that this field of study focuses on creating a system that can play more than one game successfully. There's a notable mention for AIs that also work to play video games. And throughout my my paper, I'll be doing a literature review. We'll focus on platforms that use deep reinforcement learning approach, which combines deep learning with reinforcement learning. So deep learning aspect comes from having a limited amount of information when the computer goes in to analyze the problem. Well, the reinforcement learning is just essentially like it has this limited information and then it goes through a series of trial and error where the person will update its value function based off of how it solved the problem to try to reinforce the outcome that it's looking for. So specifically, throughout my paper, I'll talk a lot about AlphaZero, which is developed by DeepMind, which is a Google company. It was developed to play chess, shogi, and Go, and it was the successor to AlphaGo Zero, which is super famous for, beating Go for the first time, beating a human at Go and doing it in a very spectacular way. But AlphaZero was able to defeat Stockfish 8, which is like the current most popular chess AI that's used by professionals to help them train, and was the world champion. It competed in a series of 100 time-controlled game tournaments, and had close to 30 wins and a lot of draws. And all this training was completing without opening books or endgame tables. So AlphaZero just played against itself like a million times and was able to do really well. I talk a little bit about it also crushing the current AI that plays shogi, and shogi is Japanese chess. So the significance of this topic is that it's well believed that creating a platform that can make its own decisions and from little human input is a very important step towards general intelligence. So if you could create an AI that has a general intelligence, it would be able to be applied to several problems outside of chess or Go. And then I also talk about the new technology that Google uses to implement this AlphaZero, which were these TPUs that they developed. TensorFlow is obviously a very popular AI development tool now. And what's interesting about the TPUs is that they are supposedly infinitely scalable because they're just chips that are able to create a mesh and just absolutely destroy machine learning. So the objectives of my paper will be focusing on the history of DeepMind and the projects that they have going in their development, talking about the AI's learning and the theories and techniques that go into reinforcement learning and deep learning. I'll be comparing the current game playing AIs that are out there, and I'll touch briefly on AI safety and the, limiting a general intelligence. So like I kind of discussed before, I'll be talking about learning methodologies such as deep learning or reinforcement learning. And then I talked a little bit about the current game playing AIs. And I also threw in OpenAI in there because I think that they're natural, because GPT-3 has a natural language processing that seems to be able to do some game playing. And specifically for AI safety, I'll talk about like understanding AI decision making and trying to have the AI communicate how it gets answers, because deep learning is too deep for us. So the schedule that I will be proposing is I'll spend 1 to 2 weeks of research, 2 weeks on creating the paper and the first draft, and 2 weeks on making a presentation, finishing the paper, and rehearsing. Yeah, and so I will be doing a literature review on the power of artificial neural networks and game playing. I'll review the companies in this field and the current theories in AI learning, as well as the perceived pros and cons of the theories. Here are my references. I'm ready for your questions.
Yeah, so you were talking about like going from like AI being good at like playing games and stuff to having like general intelligence. How does that really happen? Because I feel like when it comes to a game or something, you're really heavily filtering the information that the AI has access to, and it has a very clear end goal of wanting to win. Like, how do you go from that to general intelligence, or like how does that work?
I think that that's an interesting point. So I think I did a poor job explaining this initially, but how the learning works is that I think it's given a utility function and a goal of like win chess games or whatever, and then it develops its own strategy to do that. So one could think that this approach is very malleable because I could just point it at like create the most pencils ever and point it at, I don't know, my pencil making factory and let it go just ham wild. But the ideas of that, it's more, I think that this is an important step towards general intelligence because the deep learning allows it to be creative in a way where it's just like all solutions are open to it. And so, and we just like, cull the solutions that we didn't really like and nudge it towards a solution that we were interested in. I don't know. I think it's an interesting field.
Okay, thank you.
Nobody has any more questions? If not, then that'll be it. I believe she was the last person that had to go. She was the last person. I think we just go back into the regular meeting now.